Welcome back. So we have scenarios where data protection solutions that use encryption keys or digital signatures requiring the use of private keys is critical. Hardware security modules, or HSMs, provide a tamper-resistant environment for managing these keys. In this lesson, we're going to talk about CloudHSM, which is Amazon's solution to scenarios where your own encryption keys are subject to corporate or regulatory requirements and therefore need validated control. So CloudHSM is a dedicated hardware security module solution. It conforms to FIPS 140-2 Level 3. Now, FIPS is a US government computer security standard that's used to approve cryptographic modules. And it has a number of different compliance levels. Now, compliance level 3 is where physical security mechanisms might include the use of strong enclosures and tamper detection or response circuitry that zeroes out all of your plaintext cryptographic security providers when the removable doors or covers of the cryptographic module inside are opened up. Now, if you remember when we talked about KMS, KMS is level 2 compliant, which simply needs to show evidence of tampering. So this is key for the exam, because if you see any questions that reference FIPS 140-2 Level 3, the answer is always going to be CloudHSM. Now, the difference between KMS and CloudHSM is that you manage your own keys with CloudHSM. CloudHSM offers a single-tenant, multi-AZ cluster. It's dedicated to you. KMS is multi-tenant. It uses HSMs internally, but those are shared across customer accounts. Now, because it's a managed service, you don't have any access to the AWS managed component of CloudHSM. You keep control over your access keys, and AWS themselves don't have any access to your keys. And CloudHSM runs within a VPC in your account. We'll talk more about the architecture in just a second. So like I said, CloudHSM is a single-tenant, dedicated hardware solution that runs in a multi-AZ cluster for high availability. It also works with industry-standard APIs. There are no AWS APIs available for CloudHSM. So if you have software solutions that require compliance with PKCS number 11, Java Cryptography Extensions, or JCE, or Microsoft CryptoNG, CloudHSM is the solution for you. Also note that you have to keep your keys safe with CloudHSM. If you lose your keys, they're irretrievable. So now let's take a look at the architecture here. With CloudHSM, you first need to create a cluster in either an existing VPC or a new VPC. So how this works is that CloudHSM will actually operate inside its own VPC dedicated to CloudHSM from a security isolation standpoint. CloudHSM will then project ENIs, or Elastic Network Interfaces, into the VPC of your choosing, and this is how your applications communicate with the CloudHSM cluster. Inside the cluster, you'll create specific instances of HSMs. Now, CloudHSM is not highly available by default. You'll need to explicitly provision HSMs across availability zones like I have here in the diagram. If any of these HSMs fail, or if any AZ becomes unavailable, you'll still have the other HSM instances. Ideally, you'll want to place one HSM per subnet in each availability zone, with a minimum of 2 AZs like you see here in the diagram, which is what's recommended by AWS. So for the exam, know that if you have strict regulatory compliance requirements, or if you have FIPS 140-2 Level 3 in the question, you'll probably want to choose CloudHSM. So that's about all I wanted to cover on CloudHSM. If you have any questions, feel free to reach out. If not, move on to the next lesson. Thanks.